Hello, this is Trevor. Today we're working on the Solve Me challenge in the Down Under CTF 2022. This is the easy blockchain challenge. And if you read the description, all we have to do is call the solve function. And we're given the Solidity contract right here. So in this video, I'm just going to walk through how I solved it. I'm not the best at blockchain, so if you know of a better way or things I could have improved on, please let me know. But for everybody else, hopefully you find this interesting. So we're given this URL, and I've already got it pulled up here. What it shows is the RPC endpoint for the private blockchain, the port, and the chain ID, as well as 3 API endpoints. The most important to us right now will be this challenge endpoint. This will give the information we need, like our wallet address, private key, our balance contract address of the Solidity contract right there. I've also opened up Web3 Pi. This is the API I'm going to use, or the package in Python, to communicate with the blockchain to solve this challenge. We need a few things set up. So number one, I need the Solidity compiler. As you can see, I already have that installed, ready to go. This will allow us to compile the contract and get the ABI, or the application by binary interface. I believe that is what that is. We also need Web3 Pi installed. I already have a virtual environment in Python created and activated, and I have the, if I do pip freeze, you can see that that package is already there, along with a few other things like IPython, just to make it easier. All right, well, let's, without further ado, let's get started. So the first thing I want to do is I want to pull in all that information from the APIs, just so I have it at my fingertips. So I'm going to go here and I'm going to call it info equals requests.get. I'll paste that in, and I'm going to convert it from JSON, if I could put that in. Now we have all of that easily at our fingertips. I also want to note down the chain ID, which is 31337. And I think that's everything I need for now. I'm going to import, I'm going to do from Web3 import Web3. And because I know I'm going to need it, I'm going to do from web3.middleware import get POA middleware. And we'll talk about that. I'll show you why it's needed. So we've got all the pieces now. I'm going to create our first interface to this RPC thing ready to go. RPC interface. It's a remote provider, so I can just copy and paste this, replacing the URL for the, and I don't have it, so I'll just do a single quote and go here. Copy link address, paste, close that. Now, if we try to, if I do eth.block, get block latest, we're going to get a failure. And that's because Web3 Pi is expecting to be on the, the canonical proof of stake chain. But in this challenge, we're on a proof of authority chain. And so we need to tell Web3 Pi, don't use the same settings you used there. Instead, use this, and we're going to inject middleware to make it, to fix that difference. So I'm going to, let me clear this so we're at the top of the screen. I'm going to do W3, and that's why I imported this before. So where middleware onion dot inject geth POA middleware layer equals 0. So that's the proof of authority. Now, if I run the get block latest, you can see no errors, and I do get that block. Sweet. So we've got a good connection to the RBC endpoint for this blockchain. Now we need to create a handle to the contract. In order to do that, we need two pieces of information. One is the contract address, which we already have, and the second one is the ABI. And that's where this Solc compiler comes into play. So if I go ahead and compile that, and I'm going to do that with solc -ABI solve me.sol-o build to, place that output in build directory. And whoops, I already have it. Let me overwrite. There we go. If I could do tree, we can see that solve me.abi. So cat solve me, build /solve me ABI. And there's the application binary interface that we need. And this will allow Web3 Pi to know what the contract interface points are. So we need to import that. So I'm going to do import JSON ABI equals JSON.loads and paste this in. There we go. Got the ABI. We already have the contract address, and that's in info. So we are all set to create that contract handle. So I'm going to name it solve me equals w3.eth.contract ABI equals ABI address equals info contract address. This is, it has a list, so it's the first one in the list, and then get the address. Sweet. So boom. We can do, like, now that we have that handle, we can do stuff like solve me.functions.is functions.is solved.call to interact with the contract. Some interactions, when they're read only, are free, right? So I'm just getting information. I don't have to create a transaction or spend money. I can just call that and get the information back. You can see it's not solved right now, and that's what we need to change, because I will be modifying the data stored on the blockchain that will require a transaction that is signed, and I have to pay for it and all of that stuff. All right, so that's our next step, is to build the transaction. So transaction equals solve me.functions. Solve challenge. Remember, we saw this this name, solve challenge, in the right here. So that's how we know that. And right now we're going to build transaction based on that. This is going to be a dictionary object. So I'm going to just do this. And number one, I need chain ID because we're not working on the canonical chain. Did I save that? Well, it's 31337. Next, gas, we need to pay for this transaction. And I don't know what this is going to cost right now. I'll fill in something and then as a placeholder and then come back after we have the transaction created to override both the gas and the gas price. Again, I don't know the price is currently, so I'll just put anything there. And then from, I want to put my address, which is in the info. It's in player wallet. And it's in the address. Okay. Finally, I need a nonce. And this helps protect against duplicate transactions. There's a fancy word for that, and I can't remember what it is. eth.get transaction count. And the nonce is just a counter, and it goes up by 1 every transaction. So I'm going to just get transaction count for my address, which is, again, info, player, wallet, and address. And then I'm going to add 1 to it. Doesn't matter if I miss a transaction. Well, kind of does, but this is fine. And then I think that is it. So instead of trying to make it pretty, I should just only int to string. Oh, right here. Let's do w3.eth.get transaction count info player wallet address. Let's see what that returns. 0. So we can do the same thing, but just have it be 1. Since there's no transactions, the first one will be 1. And oops, that's probably where I messed up. All right, let's try that. Perfect. Let's take a look at the transaction. Everything looks fine there. As I said, I want to replace both the gas price and the amount of gas that I'm willing to do for this. When you're doing Ethereum transactions, you can mess with the gas price as much as you want. That's not really a big deal. If you're too low, it's not going to get picked up and your funds are just going to stay there. You won't be able to use the wallet until that transaction either drops out of the mempool or it gets picked up and put into a block. Gas, on the other hand, is a different story. So this is the gas right here. This one is the number of units of gas needed for this transaction. If I put this too low, that means that someone will get it, start trying to execute the transaction, and by someone I mean a node, an endpoint, a validator, will start trying to execute this transaction, realize that there's not enough gas paid for, drop the transaction, and you will lose all of the gas that you paid for. If you put your gas estimate, higher than what it actually used, you'll be refunded. So be very careful, like if this was a real transaction, messing with the gas. Fiddle with the gas price all you want. Again, not much harm, but you'll lose your ability to make transaction until either it drops out or is included. Okay, with that in mind, let's get the gas price. We can do that by w3.eth.generate, and we're just going to use a simple gas price equation. I expected that to return some info. gas price API. What did I do wrong? Generate gas price. I don't think we can use Web3. I think we need to use, W3. Well, I don't know what the gas price is. So I guess if we're going to leave it at 10, which I don't know if that's going to work or not. All right, now let's estimate the amount of gas. We have a transaction ready to go, so we can use that by doing w3.eth.estimate gas of that transaction. So this is how much gas units it's expecting to use. So I want to put over that. So in the transaction, I want to put the gas at, let's do 60000. And, that's not quite 50% more, but close to 50% more than what it expends. That to me is safe. Next up, we have the transaction ready to go. We need to sign it. So signed transaction equals w3.eth.account.sign transaction. We're going to give it the transaction. We need to give it the private key, which is in the info player wallet, and the private key. That should sign the transaction. And then finally, we send it. So w3.eth.send raw transaction signed transaction.raw transaction. Here we go. That gets the transaction number back. And remember how we interacted with the solve me dot, right here. Solve me is solved. Let's call it. What? Damn it. Maybe it hasn't been mined, or maybe our gas price was too low. There's a way that we can check that out, but let's check our transaction. Let's add like 2 zeros to the gas price, because it's too bad we can't get this to return something useful. So let's do gas transaction gas price equals, let's try that. It's in way, so that's still, extremely cheap. Oh, we need to change the nonce too. Transaction nonce equals 2. Send raw transaction. No, we need to sign it there. And then we can send it. And we can view the results. Let's still false. Let's view the results. So let's get the transaction results. And we want Web3 Eth API count block do transaction get block. And it could also be that the hasn't been included yet, but I don't think that's true. Get transaction. This is what we want. Web3 eth.get transaction. Let's see. w3.eth.get transaction. Block hash, gas price, nonce, chain ID, which was right, hex bytes. So it doesn't give us the transaction index. Hasn't been included. This might be a case that the site is now no longer, because this is after. So we could have done everything right. There's just no node that's including transactions onto the chain. This is just sitting in the mempool ready to go. If I was smarter, I'd be able to pull up the mempool to check. Let's check the latest block again. We just did w3.eth.get block latest. Proof of authority, gas limit, gas used, timestamp. So what's the current, is it date? No, time. Dang it. How do you get the UTC time from epoch to date time? Whatever. GMT, your time zone. Oh, suck. So yeah, that was a couple hours ago. An hour ago was the last block. Yeah, too bad. All right, but I think we did everything else right. We've got 2 transactions in the mempool ready to go. So if they ever do turn on the validator, miner, the whatever person that includes it, this challenge would then be solved. Anyway, I hope that was interesting. This is the way I solved it. I don't see a lot of write-ups for blockchain. They're very cool. Of course, I am just a beginner at it, but hopefully this was useful. If you have any questions, as always, just let me know. Otherwise, I'll see you in the next one. Thank you so much. Goodbye.